So, or we can just say, you know, I want more examples on ratios. I want more examples on scientific notation. Whatever you want, we're going to come up with, and we're just going to do today. So it's kind of, it's a whatever you want, nothing really planned. This is the only slide I have done for this particular time. So we've gone through officially 5 sections, sections 1 through 5, and a lot of people have been working and have a lot done in web work through those 5 sections. So on Wednesday of this week, we are going to go through sections 6 through 9, and there are people that have already started those as well. So we can do questions over anything. I mean, if you pick, you know, you want to do a question over section 6, even though we haven't covered it yet, that's totally fine. We can do anything you want. So, all right, so Jessica's giving me permission to go into her web work. All right, which problem do you want to see? I know you had emailed me, I think, section 2. So we can bring up yours, and that might help others depending on what. There's a couple problems in section 2 that are a little bit, well, a pain in the rear, to put it nicely. So as I'm waiting on Jessica to kind of give me which problem she wants to see. As you guys are, you know, sitting here, and you know, thanks to the 3 of you that are here, if you want to kind of go through, you know, the course on your computer while you're thinking, and you can just put problems in the chat box, you know, WebWorks 6, number 5, whatever, and then we can bring them up. And we can talk about those kind of problems in general. If you want to like work on yours later and you want to be able to do it from scratch, I can come up with one that's identical, you know, pretty similar to what you're doing, but not yours exactly. So, okay, I'm going to go ahead and go into web work, and I'm going to go into Jessica's since she gave me that permission, because I know that she had some questions. So this is everybody in the class. Can't see anything from this page. So there she is. All right. So Jessica, I'm going to go into section 2 because I think that, yeah, down here in section 18, I think is where we were discussing. So this problem has caused headache to quite a few people in this course, and with good reason. It just has a lot. First of all, you're given the problems in numbers and percents for 4 different regions. So there's a lot of spots here where you can really just jack it up. So, all right, so looking at this, so we can see that, you know, Jessica got the part 1 taken care of. And the issue with part 1 that a ton of people have issues with is that they tell you up here the numbers are in thousands. And what that means is that all of the number columns, so when you look at the number columns, you have to basically add 3 zeros to those. So the Northeast numbers for both sexes, you got to add 3 zeros. That's 54,782,000. And so if you don't catch that thousands, that really jacked up part 1. All right, so we have part 1 taken care of, and those numbers are going to be crucial, right? So the under 15, that is the total for your children. The 15 to 64 is the total for your working class, and over 65, there's your old people. So when you get down to section 2, we're talking about under 15-year-olds to the total population, and we're looking for a ratio. So under 15, all right, let me make some notes because I want to go back to a different page where I can show some work here. I've got under 15 is the 23,671,000 people. Now the total, we haven't calculated the total population, but if I add those 3 numbers together, right, the A, B, and C, the young people, the old people, and the working class, those 3 numbers together are going to give me my total population. So can any of you add those up just so that we can double check our math, because sometimes it's easy to make a mistake. So if any of you can give me your total for those 3, adding A, B, and C together in part 1, I want to double check my work. 11,327,4. Yep, okay, so we got the same number. So there's our total. So when we're going then to find our ratio of under 15, I'm going to go back to this and I'm going to get myself a new slide here. All right, so blank. So when we go under 15 to the total, right? This is our ratio. When we talk about a ratio, whatever number they give us first, that goes on top. So under 15, and I don't know about you, but I'm not a big fan of brown. Under 15, that was our 23,671, and this is from part 1, right? Then you found your total, which we both just found to be 11 million. Actually, shit, I put that in the wrong spot. Okay, ignore that little comma there. 113,274,000. I don't know how to just erase one piece. There's a highlighter, there's a spotlight, there's an arrow. Yeah, whatever. Okay, so we have our fraction here, and you'll notice that when you're doing these fractions, I'm going to say almost always the numerator is going to be smaller than the denominator. And if the top number is smaller, when you divide these to turn it into a decimal, you're going to have a number less than 1. So if we go ahead and divide these two numbers, so 23,671, couple zeros, divided by 113,274, couple zeros. There you go. Okay, so we have 0.20897. I'm going to go 5 places for fun. Okay, so that's our ratio. But if we go back to the problem, let me get going back to this, the question says, express your answer rounded correctly to the thousandths place. Okay, so thousandths, if we remember correctly, I need a different color. Thousandths is here. So I look one past, 9 tells me to round up, so I'm going to be at 0.209. So this is part A for number 2. And feel free to unmute yourself and scream at me if you have questions, or in the chat box. Either one is fine. But I think you are all self-muted, so you should be able to unmute yourself, I believe. Okay, so part A is the 0.209, and you might have to have a 0 in front of that. It's very possible that WebWork is picky. This is a part-to-whole ratio. That is true. That means there are 209 people to every 1,000. Okay, so C and D, we have a minor issue. Okay, so let's go back to our page here. I'm going to clear this out, erase all drawings. So we know that we are at 0.209 to 1. So in that first one, if you want to talk about per 1,000, right, that's moving the decimal 3 places. So if I move my decimal, my numerator 3 places, that gives me 209. Right, and that's, you had that one. If I go back, part C, this means there are 209 people under the age of 15 for every 1,000 people. Yes. Okay, now in part D it says, what if we have 100,000 people? So, I mean, same concept here. So we're now going to go, we want 100,000 people. Well, from 1,000 to 100,000, we're adding 2 more zeros. So I want to move my decimal 2 more places. If I move it 2 more places, that gives me 20,900. And that's kind of how you can think. These are all equivalent fractions, if you think about that. So that's a way to kind of think through the pieces. And one thing that I want to mention, you'll notice in this problem, we are talking about a part-to-whole ratio. We're talking about a portion of the population, the under 15-year-olds, and we're relating it to everybody, to the total. That's why we're talking about people. When you start talking about dependency ratios, then we're talking part to part, and then you got to talk about workers. So it's super, super important that you pay attention to who you're talking about in these particular problems. Okay. All right, so Jessica, does that make sense on section 2?
Yes, that does.
Okay. Okay. So if you understand that, and you had 2 of the 4 correct, and I think in part A, I think you were there. I mean, you had the right numbers. You just had your decimal point, in the wrong spot. But when you go to section 3 and 4, it's going to be almost identical in terms of work. You're just going to be using, for the 15 to 16-year-olds, you're going to use the working class for your numerator. And that will change, obviously, then your decimal will change, and that will also change then your numerator for your fractions.
Okay, Becky, real quick.
Sure.
I clicked, well, as we were going through it, I went back to mine, and I clicked in what you showed us, and I went to click enter, and it's not letting me go to section 3. Or do I have to submit?
You have to, yeah, you're going to have to submit.
Okay.
Yes. Yes.
Gotcha. Okay.
Yep.
Oh, well, it's saying I'm wrong there.
It's actually off. The decimals are kind of off.
What do you mean the decimals are off?
When I did the problem, I got 0.2122, and then still part to whole, and then when you move the decimal to get the rest of them, it's like 212.2 and 21,220.
Did you use the same numbers that we did?
I think so, and it let me move on.
Huh.
Okay, hold on a second. Okay, so, well, Abby, are you talking about in your problem?
Oh, true, yeah.
Okay. You might have had a different
okay.
different region, because I was like, wait a minute, this is weird. Okay.
Sorry, it was like slightly off, so I didn't know if that was like.
No, you're good, because that almost gave me a little heart attack. But that's
okay.
Okay, sorry. Jessica, the issue with your last one, you can see it showing up as incorrect. Weber does not like commas, and I don't know if I've.
Oh.
So if you just take out that comma between the 20 and the 900, it'll be perfect. Yeah, that'll be good.
Gotcha. Yep, now she's happy.
Okay.
Okay, thank you.
Yep. All right, so that kind of is 18 in a nutshell. And then, did we need to talk about 19 also? Yes.
Yes.
Okay, so
I got stumped on both of these questions.
Yeah, so it looks like you got through 1, 2, and 3, which is the dependency ratios. That's where we're comparing the, people who are dependent compared to the entire working class. So when you come down to the interpretation here in the second part, remember that with dependency ratios, you're always comparing to workers. So for any problem here, like if I just look at this first one, the child dependency, I know that C and D are definitely not right because they talk about people. I'm not comparing to people, I'm comparing to workers. So that's a very, when you talk about people, you're talking about everybody. And when you're talking about age dependency ratios, we only compare to workers. So that's kind of a small detail that makes a huge difference. So you can eliminate C and D completely from the first part. So then when you're thinking about words, Becky, words. When you're thinking about A, B, and E, do they work? Well, when you're talking about dependency ratios, so in this case, we're talking about children compared to workers. Those are both part of the population, so we have a part-to-part ratio. And hopefully you caught this when you were working through the packet. Part-to-part ratios can only be written as a decimal. They cannot be written as a percent. You can only write part-to-whole ratios as a percent. So that's going to knock out part E, or at least it should if this is done correctly. Close your eyes for a second.
I'm terrible with the interpretation.
Yeah, and this class, that is crucial. Okay, so, yeah, okay, good. So you got part, hold on a second. First one's good. So the child dependency ratio, A and B, is the correct answer.
Oh, okay.
So then when you're working through the second one, again, you're talking about a dependency ratio. Okay, so looking A through F, knowing that it's a dependency ratio so that it's part to part, Which ones can you automatically chop out?
Well, definitely A and D,
Okay.
since they're percents,
Uh-huh.
right?
Yep.
Okay. Definitely cross out C.
Yep.
And
Why is B not the right answer?
yeah, I was very
Oh,
saying,
it is.
so it should be
Shut up.
B.
You're good. That one's right.
Oh, okay.
That's
I was
what
about to say that.
I was
That should
like,
be right, right?
I almost had a heart attack there too. Jesus, it's definitely a Monday. Okay, yeah. So good. Okay, those are the key things that you're looking for. All right, so then we go to the last part. Look at, so right now you have marked B and E. Which one of those is not right?
E, definitely.
Exactly, because it says people, we don't care about people. So you got to go back and see which ones are they talking about workers, and then which ones make sense. Like if you look at letter C, it says approximately 48 workers in the Northeast region are dependent. So they're talking about workers, but that doesn't make sense, right? Workers aren't dependent on anybody. They do their own business. So
right.
So you kind of got to look for, the different pieces. Yeah.
Okay.
It's the details.
Yes, yeah, I'm terrible with the interpretation part.
You'll get better because you're going to do a lot of it.
Okay. Well, good.
Yes.
I need it.
Positive and a negative all at the same time.
That's all right. I'll take it both.
Okay. So with those hints, hopefully you can take care of that third one pretty easily. All right.
Oh, no.
What other kind of questions do we have besides those last two in section 2, which are beastly?
Let's see. I know I had in section, what section was that? I think I was in section 5 where I had a couple of questions.
Section 5. So let me go to homework sets. I think I'm still you. Yep, I'm still you. Number 1?
Of course, the last two problems. Now the last two problems.
In section 5?
Oh, why am I in section? No. Sorry, I'm in section 2. I thought I clicked on section 5. I'm sorry.
You're good. You're good. I'm like, we're not looking at the same thing.
No.
Okay, so in section 5, it looks like number 1 has caused you issues.
Yes.
Oh, yeah. Oh, yeah. Okay. Go ahead.
I don't know why.
I think... Oh, that's not it. This one doesn't have a video with it? I've totally made
it. It didn't for me.
I totally made a video for this problem. I don't know why it's not in there. Let me write myself a note for that, because the thing that bothers me is when I make videos and then they don't get put in, because if I spend time doing them. Okay, so section 5, number 1. Okay. All right, so basically, I mean, you got the right answer, right? The answer is x equals 4. So when you're thinking about this, to isolate the variable, right, to get x by itself, you want to undo whatever mathematical operation is there. So right now, if you have 3 touching the x, what does that represent?
Multiply.
It represents multiplication by 3. All right, what is the opposite of multiplying?
Dividing.
Dividing. Okay, so the opposite of multiplying by 3 is dividing by 3, so letter C is the correct answer. Now, if you are multiplying, that has nothing to do with subtracting or adding. So anything that says addition or subtraction needs to go away. All right, because those adding and subtracting are best friends, multiplying and dividing are best friends, but they do not commingle. Okay, so when we go back to our blank screen here, so I can show this. So if I have, let's just stay with 3x for fun. If I have 3x and I want to make this right a 1, so we just said we can divide that by 3. So if we divide both sides by 3, 3 divided by 3 gives me 1, and that's what I want, right? That's one way to get it. All right, well, now I want to focus on just the piece that we talked about, the 3x over 3. So if I have 3x, and I'm talking about dividing that by 3, right? So notice I wrote this a little bit differently. Darn it. Change colors. Because if you can think of this as fractions, right? When you divide something by 3, you're basically putting the 3 in the denominator. So dividing by the red 3 is the same as multiplying by 1 over 3. Right? Because dividing by, if you think about back in the day when you talked about dividing fractions, dividing by 3 is the same as multiplying by the reciprocal. Does that sound familiar from way back in the day? Yeah, so
Yeah.
if you go back to the problem, you know that dividing by 3 is one of the right answers because we talked about that, but also multiplying by the reciprocal, which is 1/3, is the answer. So C and F would both be correct because you're dividing and multiplying by the reciprocal. The subtracting in part A has nothing to do with it.
Okay.
Yep. And you're trying to get x by itself. So like the dividing by 3x, if you divide by 3x, then you have moved x to the other side, but it's still not by itself. So you never want to multiply or divide by the x because that just complicates your problem.
Gotcha.
Yep. Does that make sense? And I think the next problem, there's another one similar to that, but I don't know where that's at.
Yep, no, that should be correct.
And Abby and Yarley, feel free to chime in with problems that you want to talk about or concepts, whatever. We can go back and forth as much as you'd like.
I do have one question on Section 5, Problem 9.
Section 5.
Becky.
This is
in that.
Jessica, right?
Oh, sorry. Yes.
Okay.
Sorry.
Okay.
Yep. It says the ratio is feet to inches.
Uh-huh.
Do I go ahead and take that 1.5 feet and turn it into inches to get my answer?
You can do this a couple different ways. You can do it the way that you're thinking of, but it's going to be more work. But if that makes sense in your head, you can. You know, when they give you this problem, 1.5 feet of snow will melt into 2 inches of water. So if you think about that, 1.5 feet will melt into 2 inches of water. So this is feet of snow, and this is inches of water. And then they can say, okay, the second half of the problem says something, if I could go back to it. During a winter season high in the mountains, 215 feet of snow, how many inches of water will that be? Well, so they give you feet of snow. So feet of snow goes on the top, so 215 feet of snow will be how many inches of water?
Okay.
So this is the easier way to do it because then you can just solve that proportion and you'll have the number of inches of water that it will melt into, if that makes sense.
Okay. Yes, it does. And of course, I want to do it the more simple way.
Anytime they give you a comparison, 1.5 feet of snow is 2 inches of water, that's a ratio, right? Because a ratio is a comparison. And then if they continue to talk about it, then you can set up the proportion because you can set the two comparisons equal to each other.
Okay, that makes sense.
I was having trouble on the orientation problem 6. Like, it wouldn't let me.
Oh, hell, I hate that problem.
Yeah.
Yes, I believe if I can, every semester they tell me, oh, we fixed it. And every semester, that's the one where it says, I'm just going to continue to use Jessica here since I have yours up and you gave me permission. It's number 6, right?
Yeah.
Yeah. So this is the one. Go back and review. See how I have a solutions button right here?
Yeah, I don't have that.
Right. It shows up for instructors, but it doesn't show up for students, which is why every semester they think it's fixed because the person who does the coding is an instructor and they have the button. So this button, if you hit it, it's supposed to say enter yes. So the answer is just yes. But if you don't have the solutions button, you can't find that. So anybody who emailed me, I gave them the answer. But I made people email me and ask me about it. Since it's not for a grade, I don't get too excited about it, but man, I hate that question. Yeah.
Okay, and then I still wasn't getting section 2, my problem 18 and 19.
Okay. Were you on the about 20 minutes ago when we talked through Jessica's 18 and 19?
Yeah.
Did that help at all make any sense? Were you working on them as
I tried, but it's still not right.
Okay, so let's bring, do I have your permission to bring up your web work? Okay, so let me go to my class list editor. There we go. Oh, look at all these active people in here. All right, so now I'm number 2, problem 18. All right, so the first issue is, we're in the Northeast region, is going to be to make sure we have our numbers added. So Northeast is our third numerical column over. So we need to add up our under 15. All right, so have you added these together already?
Hold on just a second. So it's just like, wait.
So that's not right. Okay. Okay, so for total population for under 15, so you're using the column that says Northeast with the number sign, right, the hashtag there. Okay. And for under 15, you've got to do the under 5, 5 to 9, and then 10 to 14.
Okay. I got 10,034.
All right. Now, the thing to remember, we talked about this earlier, right? It's in thousands. So take that number and add 3 zeros to it, because in thousands mean you got to add 3 zeros.
Okay.
So 10,034, add 3 zeros. So there's your under 15 population.
Okay.
Then for the 15 to 64, you've got to start with the 15 to 19 and add all the spots till you get to the 64. And that one tends to be trickier because you got to make sure you get them all.
Hey, stop it. No. Stop. Sorry about that. Can you hear the barking?
Yeah, it's all right.
Sorry. Why is that stuff?
I got 47,135.
Oh, 47,000? Oh, did you add your under 15 people to that? Yep, you did.
Probably.
Yeah. So you want those to be 3 separate numbers. So your 10,034 is one number. Then you want to start. So just take your 47,000 that you just got and subtract the 10,034. That'll get your 15 to 64.
37,101.
There you go. There you go. And don't forget to add the 3 zeros when you put it in the system.
Okay.
And then, so you're 65 and over, you're going to start with your 65 to 69-year-old, and you're going to add those last 5 numbers together.
Okay. $7,647.
Yes. Okay. Did you type those in?
Oh, yeah, hold on. I put in commas, so that's why.
Yep.
Kind of
Good.
Okay, yeah, those are all correct.
Okay, and you hit submit.
Yes.
Okay, so let me refresh my page. Why is it not showing up? Okay, let me go in and out. Do this again. Wrong person. There we go. Okay. All right, so now this is now similar to what we did then with Jessica. So now you have your totals, right? Your totals for each individual group. To find the overall total population, you will add those 3 numbers together. All right, so let's do that first.
$54,782.
There you go.
Right?
Yep. All right, so now when you go to sections 2, 3, and 4, they're all done very much the same way. And you're comparing,
Okay.
you're comparing the groups. So for the first one, you're doing the under 15 to that total we just had. Right? So
Okay.
your under 15 was the 10,034,000 over, man, that's kind of sloppy, sorry about that, over the 54,782,000. So the first step is to divide those and get yourself a decimal.
.1831.
Yep, and we want to go to 3 decimal places. So if I'm at 0.18316, I just went out a few spots. So 3, it says go to the nearest thousandth, so that's to the 3. Does this one tell me to go up or down?
Down.
Down, exactly. So our first one would be 0.183. Now, just thinking through this, that's over 1, right? So when you move forward to do the comparison to 1,000 people, well, from 1 to 1,000, we added 3 zeros, which is 3 decimal places, basically. Right? So you move 3 decimal places in the top, and you get 183.
Okay.
Similarly, if you want to go to 100,000, well, from green to orange, I need to add 2 more zeros, which is 2 more decimal places. So I got to do the same thing in the top and the bottom, which gives me 18,300. And this is what the process that you're going to go through for parts 2, 3, and 4. They're just with the different sections of numbers.
Okay.
And we're going to get to the total population. So in this problem, we're talking about people, because total population is people. So that's kind of the comparison that you're dealing with in this problem.
Okay.
Does that help kind of get you on the track?
Yeah.
Okay. So then,
Becky, I went back through on the pretty much the same problem what you guys are doing, problem 19, I believe. And on the extended part, would that be, you would use that same technique for the extended part, right? Where it's asking about the baby, well, mine says baby boomer, so subtract the 65 to 69-year-old
oh, yes.
ratios.
Okay. I have a pen. That's why I can't move my screen. Okay, yes. So doesn't it say take the 65 to 69-year-olds and make them part of the working class?
Uh-huh.
Yeah.
Yes.
So, okay, so doing that, moving forward then, you would take that 2207, you would subtract it from the old people and add it to young people, or to working class. And so that would change those two numbers, the working class number and the old people number. Right? You got to take it out of the old people and put them into the young people.
Okay, and then add it into the,
To the working class, yeah. So if we're talking about, we'll just use Yarley's numbers here because that's what we have. So the 15 to 54s, that total for this problem is 37. You know, and your numbers, Jessica, will be slightly different because you're in a different region. But the old people then was 7647. So for this problem, oops, that's my email. That's the wrong button. The 65 to 69 was the 2,207. So I would take, I'm going to, come on, pen. I would add the 2,207 to the working class, and I would take it away from this one.
Oh, okay. Plus with the thousands. Okay.
Right. So that gives you a new total here and then a new total here. So then you can refigure your dependency ratio based off of those new numbers. Yeah.
Gotcha.
Yep. All right. And we need to talk about number 19 as well. I think we're at.
Yeah.
Okay.
And see if that's all right.
All right. So, you know, the problem with these problems is now you have a new region. You got to do all of those addings again. So you got the part-to-part part, right? So child dependency in the Midwest region. So now we're doing the Midwest hashtag here. So child dependency is going to be, right, we want, under 15 compared to the 15 to 64. So we need to add the three numbers together to get our under 15 population, and then the numbers to the 15 to 64 population for the Midwest region. So let's go ahead and do some addition. Midwest. Hopefully you can see them on your screen. This is where having a touchscreen computer is a pain. So I like to just roll my finger down as I'm doing it. Make sure I have all my numbers. Okay, so let me know when you have those totals. I probably should go back to the screen.
Okay, I got 44,209.
That's the working class. Yep.
Okay.
So 44, 209. And if we were doing totals, we could add the zeros, but because we're going to do math and they both have 3 zeros, it doesn't matter. Okay, so now we need the under 15. Do you have that number?
No.
Okay, so under 15 is the first 3. Under 5, 5 to 9, 10 to 14.
$13,180.
All right. So back to this. Give me a pen. 13,180. Okay, so the number of children over the number of workers. Okay, let's turn this into a decimal. Because a fraction that big doesn't mean anything to anybody.
0.298.
Okay, yes, and rounded to 3 decimal places, 0.298. So there you go. So that, I believe, should be your answer for number 1. Now, just thinking through what this number means, right, the top represents children. So 0.298 children are dependent on every 1 worker. So the dependencies always talk about workers. So when you're doing your interpretation in the last part, you have to be comparing to workers because that's where we're at. And these are both parts of the population. So we have a part-to-part ratio. So you have to be a fraction, no percents. Now, one thing, you can still do the, well, if I want to compare to 100 workers, well, that moved my decimal 2 places. So I would say 29.8 children are dependent on 100 workers. You know, you can move your decimal as many places as you want, as long as you move it the same number in the bottom and the top.
Okay.
And so that's the process for number 19. But obviously the numerator will change. When you're talking about old people, you're going to use that 60, 65 and above. Yeah. But you got to find the totals first. So does that help you on that one?
Yes.
Get started? Okay. Okay. Any other problems causing you issues?
You said for our tests,
Yep.
for our exams, we have to go in somewhere.
Yes, and I'm actually going to be putting an announcement out for that.
Okay.
If you live within close proximity to an Ivy Tech, and it can be any Ivy Tech in the state, that is the easiest way to do it because the paperwork is a whole lot easier. If you live closer to, you know, IU or Purdue or any extension site or whatever, a community library, a lot of times will do proctoring. I have to have somebody who was willing to be a test proctor that is not related to you.
Okay.
People are like, oh, my sister can proctor. No, that's not really how that works. So, yeah. So if you're going to a different Ivy Tech, I don't need to know about that because I've already submitted the paperwork to Ivy Tech, so tests are good to go. If you want to take it somewhere other than an Ivy Tech location, I will need to know that this week.
Okay.
So I'll be putting an announcement out about that later today.
Okay.
Yes.
Do we still have to schedule with you before we go, or can we just go in since the paperwork's already done?
Yeah, you schedule with the testing center. Yeah.
Oh, okay. Gotcha.
I don't know anything about your exams until they show up as need to be graded on my end.
Gotcha.
Yeah.
Okay.
So, and that's your first exam. All of your exams are due on Saturday at noon because some people have work during the week and it's hard for them to get into a testing center. However, not all testing centers are open on Saturday. So it's very important that if you're taking it at Ivy Tech in Warsaw, that you look ahead and figure out when they're available, what their testing hours are, so you can get a time and day that works for you. If you wait till the last minute, I had a friend who, I think it was last summer, lived south of Warsaw, and the closest Ivy Tech he could get into because he waited so long was Gary. So he had to drive all the way to Gary to take an exam. So,
oh my goodness.
Yeah, he was not happy. And I'm like, well, served you right for waiting that long. So you definitely want to, we know that it's coming in 2 weeks, so you might want to start. We'll talk about that more on Wednesday in Wednesday's class of looking ahead.
Okay.
But that, yes, yep. And there should be information on the Ivy Tech website of where to go or where to call. I think you can actually schedule online for a lot of them too. So if you can't find that, let me know and I can find out where it's at.
Okay.
Okay. I do have a question. I guess it looks like in section 4, problem 6, I attempted it 10 times, and I guess I'm really stumped on that for some reason.
And we're back to Jessica, right?
Yep.
Got to get my voices down. All right, so let me go back to you. Section 4, problem 6. Okay, well, looking at the answer that you have in, I can already see. I don't know if your numbers are right, but I can tell you right now that it's not in scientific notation, and it shouldn't be.
Yep.
Okay.
Now that now that I'm looking at it.
We have a bunch of television sets and we have a population. Find the number of televisions per capita in the U.S. Now, so you look at the express your answer to 4 decimal places. So there's no scientific notation in that. It just wants a decimal problem. So if we have 285 million sets, we're just going to write this one out because we can. How many people did it say? I missed that.
298.4 million.
98.4. 298.4. This is kind of something just to talk about again. Well, I shouldn't say again. We haven't talked about it yet. When you're talking about a ratio, we're talking about per capita per person. Because both of these have the word million afterwards, they cancel out. So we're really only dealing with the fraction 285 over 298.4. Right? So then you divide. I think your fraction or your number might have been decent. Yeah. Okay, so what does your calculator spit at you when you divide that? Because everybody's calculators are a little bit different in how they give these answers.
I got 0.955093834.
Okay, so you want to go 4 decimal places. So 1, 2, 3, that yellow's a bad color. So 4 decimal places is this 0. So you look 1 past the 9 tells you to go up. So you should just be at 0.9551, which I think is what you had, isn't it?
Mm-hmm.
You just added some extra. Yeah, so get rid of that extra crap there at the end, the times 10 to the first, and you should be golden.
Oh. Oh, okay. Oh. Yep. That was just my issue. I guess I was just overthinking it.
Trying to add a little bit more to it than what it was asking for.
Yeah.
I always talk about this class. A lot of the math in this class is not difficult, but there are so many small details that if you miss the details, it just throws everything off. Yeah.
Right. Yep. I can definitely see that.
What else do we have?
On section 3, I had troubles with problem 8.
Problem 8. Standard notation. I think you just didn't count right. Because I'm looking at what you typed in. You know how, so the exponent is an 8, right?
Mm-hmm.
So that tells us that it's positive, so we want to get bigger. So we want to move it 8 spots to the right. And so the 7, 7, 3, 5, there's 4 places. We need 4 more, which is 4 more zeros. So I think you just need to add another 0.
Okay.
You just didn't go enough places over.
Yep.
Yeah, so sometimes I always look at my non-zero numbers. So you can see the 7735, there are 4 non-zero numbers and I need 8 total. So that means I'm going to have 4 zeros after that. So that's kind of a way to check to make sure you have enough zeros.
Okay. And then could you help me with number 10?
Also in
Also,
section 3?
yeah.
Okay, so we have some big issues here. So you multiplied 9.7 times 6.9 to get the 6.693, I'm guessing, correct?
Yeah.
All right, so the second part would be your exponential rules. 10 to the second times 10 to the seventh. If you're multiplying with the same base, right, because 10 is your base, and that's the same for both of these, what do you do to the exponents? 2 and 7. You don't multiply, which is what you did.
Add.
You add, exactly. So, okay, hold on, let me get myself some notes so I can go to the other page because we have, okay, hold on a second. Okay, so when you multiply those two numbers together, you don't automatically get the 6.693, you get 66.93. And you just said we would add the exponents 2 and 7 to get 9. However, that is not the correct answer because the first number is not between 1 and 10. Right? So your first step, and there's a couple different steps to this problem, the first thing you got to think about is how to change that. And you did this correctly where you said, okay, that's got to move over. So I'm just going to focus on 66.93. I'm going to forget this second piece for right now. If I change that to scientific notation, 66 is bigger than 10, so I have a positive exponent. So I have 6.693 times 10 to the first. That's just this blue number here. So if I bring my 10 to the 9th down, times 10 to the 9th, now I have 10 to the first, 10 to the 9th, which gives me 10 to the 10th, because 1 plus 9 is 10. So I've got 6.693 times 10 to the 10th. However, if you type that into your answer box, it's going to say you are wrong. And that is because if you look at this, scientific notation deals with the science field, and science is dumb, but whatever. Just kidding. Whatever. We deal with significant figures. And when I say significant figures, you're looking at these front numbers and how many basically important or non-zero numbers. Zeros are important if they're in particular spots, but we don't get too much into that. So you can see that 9.7 has 2 numbers and 6.9 has 2 numbers. So that means our answer, and when I say our answer, I'm talking about this piece here. Oh, where's my pen? This number here should have 2 numbers. So 6.693, I want to round that to just have these 2 numbers. So I look at 9. 9 tells me to round up. So you should end up with 6.7 times 10 to the 10th.
Okay.
And if you look at, I think most of these problems, you're going to have the hint button. After you get it wrong a few times, this hint button should appear. I think it's 3 times. You get it wrong 3 times. And I have people who type in, 1, and they just hit submit 3 times so that the hint will pop up. The video, there are video hints for all of these that talk through changing the 66.93 to the right number, significant figures, and how to round and all of that fun stuff. So when you're working through the rest of them, if you get stuck, get it wrong 3 times and your hint video will show up.
Okay.
And that will walk you through how to get from blue to pink.
Okay.
Yeah. Are one of you near a window with birds?
I'm near a window, but I don't know if you can hear the
Every
birds.
once in a while, I hear a bird chirping. Maybe I could be going crazy. It's very possible. But I'm in the
No, I hear it too. I have, well, yeah, I got bird feeders out behind me, but the windows are closed.
Yeah, my window's closed too, but
well, I'm hearing birds from somewhere. They could just be inside my head. I mean, that's possible.
I hear them too.
So we're all going crazy. I don't know if that's good or bad.
Probably.
and then for our book work,
Yeah.
we're just supposed to watch the videos and fill this out, correct?
Yes. Yes.
Okay. Okay.
And you can work as far ahead as you want. Just everything from Unit 1. So the first 9 sections, the web work that goes with it, any Excel assignments that go with it, all of the discussion boards that are in Unit 1, all of that is due on the 24th. So
Okay.
once noon on the 24th passes, I will not accept any other homework from Unit 1, and then it's all Unit 2.
Okay.
But if you take the Unit 1 test on Wednesday of that week, so, like the 21st or 20th, whatever that date is, 21st, and you're done with Unit 1, you have everything completed, you can start Unit 2 and get rolling on that without a problem.
Okay.
Everything is open. All 3 exam information has been sent to Ivy Tech. You could take all 3 exams next week if you wanted to. Yeah. I let people work kind of at their own pace with these recommended due dates to try to keep you on pace to finish in 8 weeks. But you can go faster if you want.
Okay.
Okay, that's making a lot of sense now. Becky, I do have a question on, you mentioned before that we have, well, I don't know if you mentioned this or not. It could just be me misremembering stuff, but we have to go and register each week for our discussion board class, right? On Wednesday?
The live
Or if we just register it once and then we're good?
For the Wednesday session, you register once and you're good because those are set up as recurring nightmares. And they will, you should get emails from GoToTraining reminding you you have a session coming up. I don't remember how many they send. Sometimes those go to my junk mail because I get them too as the session leader, whatever. So if you have a junk email or clutter, whatever they call it, they might be going into there. And that is where, those emails have the link where you can get in. But you will not have to re-register.
Okay.
Once you've done it, you're good. If we have any time that we have these optional questions, like right now, those will all be separate links and separate registrations because they're not on a regular schedule. So,
okay.
Yeah.
Gotcha.
Yep. But
the just double checking.
Yep. And if you, the link for the Wednesday sessions is in every week. Every week, the module, you see a live sync session, that link is in there. And I think that even if you've already registered, if you click on that link, I think it will take you to wherever you need to be besides, I think.
Okay.
If you can't figure out where to get in, you can always click on that and see where it takes you.
Okay.
Or
gotcha.
You can email me and I can send you the link because I think I have it somewhere. Yeah.
Okay.
We have options.
Alrighty.
Yep. Any other questions right now? Are you guys feeling better than you were when we started?
Yeah.
Yeah, better.
Yeah, and we can do these, they can pop up any time. You know, Jessica's the one who kind of said, I need a Monday morning session, and, you know, it's great. I'll email the link out to everybody and we can go from there. There are certain days and times that don't work for me, but usually I'm working from home a lot of times. So today I came into the office to do this, but, you know, like next Monday, if you want to do another one, I can do it from my house. It's not an issue. So just as you're working, if you get stuck and you think it'll be easier if we talk about it live, shoot me an email and we can set something up. Okay.
Okay.
All right. Okay, well then we'll conclude this. I will be working on my computer for the next 4.5 hours until I go golf. So if you guys have any questions, if you're working throughout the day today, feel free to email me and we can chat that way as well. So,
Okay.
all right.
Okay, thank you, Becky.
No problem.
Yeah.
You guys have a great day, and I'll see you on Wednesday.
Okay.
All right, sounds good. Thanks.
Bye. Yep, bye.
Bye.